supplies. Now, I'll more or less, I'm going to talk through what we're going to be doing. By the time they get here, we'll actually start it, hopefully. What we're actually starting to get into now is proofs, actually proving statements that are true, or proving postulates and theorems, and showing that they work, and doing geometric proofs. Now, this is one of the parts of geometry that most, if your parents actually, they had to do this, don't like, because most people I encounter and I talk about geometric proofs, it's one thing they hate. Now, one of the reasons is it's sometimes hard to do, but it's not really difficult once we get an idea of what we're actually doing. And what we talk about in talking about proofs, and we'll start with algebraic proofs first, is really explaining and walking through why we know each step works. We're proving everything as we go step by step, almost like a lawyer would in a court case, because this is why this is true, this is why we can say this, and going down each step. Now, the properties that we do have here on this first page are properties that you've used before. Well, we used them the other week when we solved for anything. The first one is the addition property of equality. If A is equal to B, then A plus C is equal to B plus C. Addition property of equality says I can add the same thing to both sides, and the equation's still going to be equal. Because if I add 2 to both sides, it's still going to be equal. Those work? Yeah. Okay. The subtraction property of equality, if A is equal to B, then A minus C is equal to B minus C. I can subtract the same thing from both sides. Because addition property of equality says I can add the same thing. Subtraction property of equality says I can subtract the same thing. The multiplication property of equality, if A is equal to B, then A times C is equal to B times C. I can multiply the same thing on both sides. The division property of equality. If A is equal to B, then A divided by C is equal to B divided by C. We can divide the same thing on both sides. And the last one is the substitution property of equality. If A is equal to B, then A can be substituted for B, or B for A in any equation. Well, we've done all this. Because if we think back to last chapter when we were solving for the value of x, well, we would make sure x is on the same side by adding or subtracting things from both sides. So we're using the addition or subtraction property of equality. When we try to get x by itself and I have 5x, well, we divide both sides by 5, yes? What are we using? The division property of equality. That's it. We're using this, and you've used these, but we never specifically state it as we use them. That's the real big difference. Now, when we look at this first main problem here, you're good. As we look at this here, there's going to be more steps that are going to be implemented in this first one than we will use in the rest of them. Now, I already gave us the first one. Well, the first thing is we write the equation. For us, we'll just call it the given. This is what they gave us. Now, they used the distributive property, because here they multiplied x and 3 by 2. 2 times x is 2x. 2 times 3 is 6, yes? Well, so we have 2x plus 6 minus 5 is equal to 5x plus 4. Well, from here to here, they did what? 6 minus 5, yes? So they simplified. They combine like terms. In the simplified steps, when we actually start using them, I'm just going to we won't really utilize that step because I feel like it's a little tedious to write the thing out, then simplify, then write it out, simplify, and going on. Okay. So the next step, what are they doing to both sides? Because we're trying to get x by itself, yes? So what did they do to both sides? Subtraction by 2x. So if we're subtracting something from both sides, that property, because that's what we're listing down here is the justifications, is the subtraction property of equality. Subtraction property of equality. Because that's the property that states that I can subtract the same thing from both sides and not change the equation. We still have an equal statement. And then they simplified. Thank you. Okay. That's not bad. All right. Let's look at the next step. So we'll catch you up here in a minute. We're still just on the first page. Now, when we look at this here, so here to here they simplified. Here to here. So what are we doing here? Well, we're subtracting 4 from both sides because we're still solving for x, yes? Well, the property that says we can do this is the subtraction of and then they simplified. So for those of you who are out just for a little bit there, we'll pick up on the next one because it'll be the exact same thing. Okay. So we're at the point where it says -3 is equal to 3x. Well, if I want to get x by itself, the next thing we would do is divide both sides by 3, yes? Well, the reason that we can do that is our division property of equality. And then they simplified, they actually did the division. All right. And the last one we'll cover later on, but it is considered to be the reflexive property of equality. Not for today. Reflexive. Yep. Yeah. Reflexive property of equality. All right, guys. That is mainly utilizing the different properties and seeing how can we kind of say that the property is used or exists or works. But I want to focus more on the equations. And actually doing these proofs. Now, whenever we do this, and this is really the introduction into proving statements, is that we're going to start off with this equation here. 3x plus 2 is equal to 23 minus 4x. Well, our first main step is to just write the equation. Don't worry too much about the explanation. I didn't even include it on y'all's. So we're going to write the equation. Yep. 3x plus 2 equals 23 minus 4x. Well, we want to solve for the value of x. So what do we do first? What can we do first? Yeah. So we can subtract 3x from both sides. So what's our property that lets us do this? It's our subtraction property of equality. Well, 3x minus 3x is 0. So we have 2 is equal to 23 minus 7x. And again, when we actually start working these, we're not going to be rewriting and doing the simplification step. We're just going to go on and do it. Now, what can we do next? So are all the variables on the same side of the equal sign? Well, yes, they're all on the right-hand side. We have 7x. We don't have any x's on the left-hand side. So now we need to get any other number away from x. So what two numbers are still with x? 23 and negative 7, yes? What's going to be easier to move first? The 23, because anything we can add or subtract to get away from the variable is what we want to do first, guys. So what we would do first is to subtract 23 from both sides. And again, this would be our subtraction property of equality. Because 23 minus 23 would give us 0. So I'd have negative 7x by itself. Over here we have 2 minus 23, which would be negative 21. What do we do next? We would divide both sides by negative 7. Because since negative 7 and x are being multiplied, the only way we can undo multiplication is with division. Now, the reason that we can do this is our division property of equality. And negative 21 divided by negative 7 is 3. So x is equal to 3. Now, if we wanted to, we could technically use the reflexive property of equality and say x is equal to 3 instead of 3 is equal to x. Either way still works. Questions on this here? We good with this here? Let's look at another one. And again, the reason why we're starting here is because I want y'all to get practice with explaining your steps and reasonings. Because once we get into doing geometric proofs, you have to have those reasonings. Why this works, why we can do it. So we start off with something that you are familiar with. So solving 6x minus 11 equals negative 35. So, well, the first step is the given. What are we given? What are we told? Or what are we assuming? Because we're always going to start out with given information. Here, with solving these algebraic equations, the given is just the equation itself. So what do we need to do first to solve for the value of x? we can add 11 to both sides. And if we add 11 to both sides, negative 11 plus 11 is 0, so I'm left with equals 8 or 24. Now, what's our reasoning behind being able to add 11 to both sides? Addition of now these properties that we're using for these here, I think are actually pretty easy to memorize or remember, because you won't really have to memorize it. Because what operation did we do to both sides? Addition, yes? Property of, what are we saying these two expressions are? They are equal. We're talking about an equals, we're talking about an equation, yes? Equality. Addition property of equality. So we're doing the addition property. It's just the step we're using. Now what do we need to do next to get x by itself? Divide both sides by 6. So this here would be the division property of 6x divided by 6 is x equals and that's it. Questions on this here? Do we have any questions on this here? Do we feel comfortable with this here? This is essentially what we did in Algebra 1. Y'all remember doing this kind of stuff in Algebra 1? I mean, not the justification, just the math, yes? So I want to move on to this. Yeah, number 3 I think got somehow lost in the exchange. But we're still going to be utilizing the same stuff. We're just adding one property to it. The distributive property, which just says sum, so A plus B, A parentheses B plus C, close parentheses is equal to A times B plus A times C. We just multiply A through, be it addition or subtraction, so we can simplify parentheses. So let's look at the next one. Because this really isn't adding anything, it's just we have, yeah, so it's just this one right here. So it's just the one right below that. It doesn't give a whole page, because I'll need to go back and really fix the note sheets to get them working better. So our explanation, or our equation is -5, parentheses 7w plus 8. So what would the first thing we need to do to start solving? Distribute. We need to multiply through by the -5. So -5 times 7, -35w. -5 times 8 is going to be negative, is equal to 30. And our explanation is that this is the distributive property of nothing. It's just the distributive property. The only reason that we use of equality, like the addition property of equality, is we're doing things on both sides of the equal sign. Subtraction, property of equality. We're doing things on both sides of the equal sign. Division, multiplication on both sides. With the distributive property, did we mess with both sides? No, we only really applied it to one side. Now we could apply it to both sides, but it would still be the distributive property. There's no of equality. Because even if I apply it to both sides, the distributive property on the left side is not affecting the right, and the one on the right is not affecting the left. The of equality is really saying that it is being applied to both sides. If I'm adding the same thing to both sides. If I'm subtracting the same thing from both sides. Distributive property is only affecting that one spot. Even though it could be on both sides with the same number, that one number is still only being applied to one side or the other. So it's just the distributive property. Now what do we need to do next? Add 40, which would be our addition property of show us at negative 35W, because these will cancel, is equal to 70. What can we do next? We would divide both sides by negative 35. Negative 35 divided by negative 35 will give us W. Negative, well, we know it's negative because we have a positive and a negative. It's going to be negative 2. And our last part was this here is the division property of equality. Questions on this here? How do we feel about this here? We feel good with this here? Awesome. Are there any questions on this here, solving and justifying our steps? Do we feel good with this here? Do we need to go over another example of doing this? Okay. If we feel good with this here, we'll move on to this here. I pulled those two examples out because the amount of paper that we're going to be really utilizing with this is very minimal. We'll pretty much talk about it and be done. So I didn't feel like wasting another 2 pages on this. Now, what we're looking at this here is the reflexive, symmetric, and transitive properties of equality. Now, eventually we'll talk about the reflexive, symmetric, and transitive properties of congruency, because when we're talking about congruent line segments, we can still use these properties to talk about the segments themselves, not their length, which seems tedious. Why would we need to do that? But a lot of proofs, especially when they're first coming about, were very tedious in nature. Because if I just talked about equality and not congruency, I would have to take the length, change it into, instead of the line itself, into its length, talk about the lengths of the line, and then change it back from the line lengths to the actual measure of the line. Well, that's a lot of extra steps. Because if we can just talk about the segments themselves being congruent, why have to worry about talking about the lengths themselves, their actual measure? Because instead of converting from the line to its length, talk about the length, and then convert from length back to segment, the actual line itself. If we can go from skip the middle steps, it's nice and easy. Reflexive property of equality. It's equal to itself. A is equal to A. 7 is equal to 7. The reflexive property of equality says it's equal to itself. The same length is equal to the same length. That is the same thing. the measure of angle A is equal to the measure of angle A. Well, yes, that is true. The symmetric property of equality says A equals B, then B equals A. We can flip it. Like on the first one we had, 3 is equal to X. Well, we can also say X is equal to 3. That is the reflexive property of equality. The transitive property of equality. If A equals B and B equals C, then A equals C. Because if we said B was 7, well, if A is equal to 7 and 7 is equal to C, well, then whatever C is, A and C will be equal to each other. It works out that way. We can say if AB and CD are the same, and CD and EF are the same, then AC must be equal to EF. That the measure of angle A is equal to the measure of angle B, and the measure of angle B is equal to the measure of angle C, then A is equal to C. Yeah? We are good with the transitive property. Don't apply transitive property anywhere else. It gets weird. I'm serious, it gets a little weird because, again, this is all hypothetical. Because we can say that Anthony likes Janessa and Janessa likes Diego. So by this property, Anthony likes Diego. So, again, this only really works with math. Otherwise, it gets out of context and it doesn't work. So we look at this first one here. It should be, I think, either to the left or down, to the right. If the measure of angle 6 is equal to the measure of angle 7, then the measure of angle 7 equals the measure of angle 6. Which one of these 3 properties is it? Symmetric property of, that's it. I really could have just put these all on the same page. Questions on this here? 34 degrees is equal to 34 degrees. Reflexive property of equality. And on your postulates page, that reference sheet, all of these are on there. Because I think they're right there on the front. Let's look at the next one. Measure of angle 1 is equal to the measure of angle 2. And the measure of angle 2 is equal to the measure of angle 5. Transitive, so measure of angle 1 is equal to the measure of angle 5. SATIVE. So just making sure I spelled transitive right. Property, yes, but we'll need of equality. So as long as you can write, so transitive property of equality. Now, you will need to include of equality, because as I said, we will also have these 3 properties with congruency. Questions on this here? I think these are the last 2, aren't they? I'm going to do one of them. Well, I'm not going to focus too much on the other one, because this will be our first real proof that we have. And I'm going to walk y'all through this, because this is what we're leading up to, is the geometric proofs. Now, angle 1 is equal to, well actually let's start this off properly. Angle 1 is congruent to angle 2. Sorry, angle 3. I was wanting to say 2. And this is given. Because if we look at the picture, 1 and 2 both have those markers on them, which is signifying that they are congruent. It's given to me. Because whenever we start a geometric proof, we always want to start with the given information. Whatever they tell us is true. And what we're wanting to finish with is what they want us to show. We want to show that the measure of DBA is equal to the measure of EBC. That's our last step. So really, even on the test, when we do these here, there should be some really easy ones. 1, writing down what they gave us. And 2, well, they're going to tell us what's going to be on the last one, because that's what we have to show. Now, we were told that 1 and 3 are congruent. So really, we can say the measure of angle 1 is equal to the measure of angle 3. And this here is considered the definition of congruency. As if two things are congruent, it means their measures are the same. That's just the definition of congruency, two things being congruent. Now, this is getting a little bit creative. But what I can say is that the measure of angle CBE, CBE 1 and 2, plus the measure of angle 3 is equal to 180. CBE and angle 3 will equal 180. Yes? Vertical angles. By the same property, we can say the measure of angle ABD plus the measure of angle 1 is equal to 180. Lord, it must be a Friday. Linear pairs. Sorry about that. Because linear pairs are the ones that make a straight line. Vertical angles are the ones that cross. It really must be a Friday. Now, I do know that both of these angles they're both equal to 180, yes? So by the transitive property of equality, I can say that the measure of angle CBE plus the measure of angle 3 is equal to the measure of angle ABD plus the measure of angle 1. And I'm going to cheat here. Well, okay, no. Now, what do we know about the measure of angle 3 and the measure of angle 1? They are the same, yes? So what I can do is use the substitution property of equality and replace that with the measure of angle 1. We can subtract angle 1 from both sides, giving us that the measure of angle CBE is equal to the measure of angle ABD by our subtraction property of equality. Now we're going to go more in depth when we actually go about solving these. And depending on how we look at the problem will depend on how we can go about solving it, because there can be easier ways to solve it than others. So there are going to be different ways to solve them. But your homework for tonight is not solving any geometric proofs. There are no solving geometric proofs in the homework for tonight. For tonight's assignment, you're looking at 3 through 13 odd. 3 through 13 odd. Well, number 3, you're just identifying or justifying the steps. They already have it written out for you. You're just justifying each step through. 5 through 13, solve the equation and justify your steps. So the ones we did before, so you're solving it on one side, justifying your steps right next to it. 26 through 40 even. 26 through 32, name the property that the statement illustrates. So reflexive property of equality, symmetric property of equality, transitive property of equality. And 34 through 40, use the property. So you're finishing the statement. And that is it.